This is Wizard Yaoen and Will Love Light and Magic. We just got into the fall bigram, the first yin trigram of the first broken line with two solid lines as far as we go here at the beginning of the fall equinox. Very cool, very cool. Getting cooler. All right, so I made a mistake in my last video where I left out one of the letter N's of the word Ananda. Unfortunately, I noted the errata in the notes to the video. But anyway, the video was called I believe the one-page religion of Sat-Cit-Ananda. Actually, it's the one-page religion of Aleister Crowley's Thelema, a little bit, but that's only in modern times because you can just take the Trinity from that when you step back and you're just dealing with the blank template of a Trinity, and as long as you can make cognate sense in your correlations, you have a pretty good basis for a religion going there, to tell you the truth. I'm just using that as kind of an example of how philosophically the Trinity is behind religion in general, because it contains the father and mother, so it contains the even more archetypal duality. I don't want to say duality because that sounds so disjuncted by our modern way of thinking. But when you imagine the duality as a unified complementary, then you kind of get what I'm saying. There's a built-in harmonized complementarity within the Trinity, because you're always going to have father and mother, and then the only difference between the father and mother in the Trinity is that their center point becomes separate as another thing, just like the father and mother has a child together in real life. That's the third thing in number philosophy. One of the best ways to describe the Trinity. So anyway, I made a mistake in writing the Sanskrit word Ananda, and again, the last video was on the one-page religion of Sat-Cit-Ananda, and since I made that mistake, I thought it was a perfect time to write that word right and actually get into the specifics of Sanskrit Grammatometria. And actually, I put on this black shirt and a Punisher hat even to demarcate the video specificity as the first to really get into the some examples of doing Sanskrit Grammatometria, which is pretty much the most complex language to do the process of grammatometria upon, just because from the existent rules there exist so many slightly variant orders that you could use that unless you have a decent little grasp upon the foundations of grammatometria, you won't be exactly sure of your results, and you won't really know the meaning. Their back. It's almost like their backbone. You won't really know the true backbone of what you're dealing with, the information. You won't know the veracity, the true veracity of your information, unless you have a slightly foundational grasp of the number orders you're using to number Sanskrit. And it does get important philosophically to number languages by their number orders, because most of the major languages have pretty important philosophical terms. And so we're going to use the example, since I miswrote it in the last video, the major tripart formula of Sat-Cit-Ananda, being, consciousness, bliss. It's a very wonderful formula, because as we discussed last video, it basically is just father, child, mother in that order. So it takes on some other existent tripart symbolism, and as I even described, as it relates to the Ein region of the tree of life in the Hermetic Kabbalah. So here we go. I'm going to show you the diagram before we progress any farther. And that's the big word, Sat-Cit-Ananda, Sat-Ananda Chit. I wrote it in its variant order as an example here, to map the exact father, mother, child order, so I don't have to keep specifying the difference. So this is the way it occurs at the very top level of the Ein region of the tree of life. Here Sat is Ein, Ananda is Ein Sof, and Chit is Ein Sof R. So we have withoutness, limitlessness, and limitless light implied. So let's get right into Sanskrit Grammatometria. This is kind of I would say the video on the Sanskrit Grammatometria of the word Sat-Cit-Ananda. We can still use the same order as is commonly phrased, But anyway, so I'm using, if you can just search back at my previous video on grammatometria, and you will know that I state there are 4 major non-alphabet specific grammatometric orders of any language. That's why I call them non-alphabet specific, because those are just number orders. And what I've done, and what I attempted to do, and what you can try to disprove or better your theoretical attempt upon, you can attempt to do it better. But I wager that there are 4 major number orders that most sequentially number everything. So it's kind of an interesting topic in and of itself. But we're just going on. And I've already actually stated that I think the very serial, sequential, most direct way to number any series of things is what I just call the serial order. the serial number order, the sequential number order, in other words. But I just say serial as as the most kind of brief and basic way to define that series, which I've already used in the case of the common 26-fold English alphabet. You just go serially by place value. So we're getting pretty real simple here. But that's the very foundations of Grammatometria, as it turns out. It's just really being comfortable with realizing those basic number orders and seeing those as parallel and quite important to how every alphabet correlates with each other that may not be readily apparent to just a really casual observation. Every alphabet's letter would be just logically correlated to another alphabet's letter by what place value it's in. If we could get a sure and confident theoretical fortitude upon the alphabet order's meaningful order. I got a little off track there, but you really want an alphabet order that's slightly meaningful as well. If you can, like, put some, like, we can align you could align all the alphabet orders by place value sequentially to the tarot, to the modern tarot attributions, and that way the alphabet orders and even sequential number does get attached a tarot, what I call essence. So like the number 1 is the fool of the tarot, and that's air. So the number 1 would be air. And it's pretty cool how the Hebrew aleph and the letter A kind of denote an airiness. The first rune, which would be associated with that number 1 as well, is fehu, with an F sound, fehu, but it means wheat, and it means a wealth, but by letter shape, that's a very wafting and wafting letter. So beyond the cattle, the wealth and money is also wheat. You can imagine a bunch of fehu ruins as a field of wheat. So you can imagine that as airy. And then also aleph, the Greek letter name is alpha, which is 532. And then when you use a Greek-based Latin, the Latin word akia as eagle is 532. So that's pretty cool, where eagle equals A is basically, because A equals akia in Latin. First, and then when two of the same words, not two of the same words. I'm gonna laugh at that and drink a glass of tea, a cup of tea here. When two different words have the same first letter, when you're trying to delve into alphabet letters meaning, the meanings of alphabet letters, which is slightly obscure in and of itself, but as I say and have said, that's of course the Hebrew alphabet. There's quite a bit of precedent doing exactly that with the mysticism the Jewish Kabbalah, etc. So there's history of it, and there's a lot of Greek history of it. It's just not so well known. A good book is Kieran Berry's The Greek Kabbalah, and that's a real cool book because he demonstrates that actually number practice was going on in the Greeks, within the Greek tradition first. And I can clarify my statement to mean that number play, it's basically starting out as number play. It's just like, how everybody likes to everybody that's heard of numerology kind of wouldn't mind knowing what their name equals. And it's just like, just starts out just really playing around. And maybe even for like dictative, and then you see in India even for mnemonic purposes. When you start to ascribe a number to an alphabet letter, you can kind of use it as a way to write numbers kind of easy and stuff like that. So it's not like totally all like we're trying to figure out like Pythagorean level number mysticism like my number research does tackle. But I can continue my train of thought. I must have drinking enough tea. That the Greeks were pretty much the first to use number play quite a bit with their alphabet, with the Greek alphabet. So they were numbering their Greek words. And the practice is called isopsophia, and that means of equal stones. And so when two words equaled the same amount of stones, that's how they kind of calculated them up. They would have the same isopsephic value. Isopsephic value. So I suggest kind of getting away from that technical word because we don't really use pebbles or stones anymore. And one of the cognate words is even our calculator has the origin of stones. I think calculi are pebbles in Greek. So we're not pebbling it out anymore to get them letters like Z, 26 pebbles. If I wanted to do the 26th letter of the English alphabet, Z, I'd have to roll out 26 pebbles. That's why they didn't do that in Greek. The classic number order was what I call the metric order, and that's like one of the 4 major non-alphabet specific grammatometric orders, but it's the last one because it numbers the highest number range, and it's also the easiest. Oh, no, it's not. That would be the hardest to use. What was I thinking? Yeah, I thought the Greeks had it down so where they could actually cheat and use a real low-level alphabet order, but they actually didn't. The serial order for them would have actually been the easiest, but no, it was the metric order that had the most classic use. So where Z in the 26th place value, that would equal 800. So that would equal 800 stones right there, just with their, that would correlate to the Greek letter omega. Omega equals 800. So the alpha and omega is 801. That would be a parallel in Hebrew. The alpha and omega is A and Tav, which is their 22nd letter, which is 400 metrically, has the value of 400. So that's 401. And that means essence. That word, there's a word that means essence composed of Aleph and Tav. So it's kind of interesting there. 401 is essence. I'm not sure about 801, but that would be kind of the essence of the Greek alpha and omega, and the Greek alpha and omega. But anyway, we're skirting away from the topic, which is the Sanskrit Grammatometria. And as I say, I made like we're kind of punishing it. Once you get into Sanskrit Grammatometria, and you can kind of know what you're talking about a little bit, as far as Grammatometria goes, your punishment. That's why I wore this special gray and black Punisher hat in honor of the fact that I actually had even rolled it out to the, let me see if we can roll, nope, to this level of video series magnitude. Malku. There we go. So this is Sat-Ananda Chit, spelled out correctly. Still got scrunched. That needs quite a bit of room. The Ananda. I had to scrunch the letter N that I forgotten last time in, even to really make this even at this. It's called what, landscape formula when you go to print this type of paper. It's just the so even at this wide use of the papers, that Sat-Ananda Chit gets slightly scrunched. I would have to write that a little bit better. The N and the D. This is the conjunct. There's only one conjunct letter of that tripart word, and there's an N and a D. There's the 20th letter na, which is right here, but the 20th letter na gets conjuncted with the 18th letter da as the last conjunct letter of the word Ananda, which means bliss in Sanskrit. So that last part of the word, Ananda, it's composed of the 20th letter na. It just sounds like a normal na sound, that one is, na. And then its conjunction with the 18th letter da, which is just a normal da sound. So it should be quite easy to say Ananda without too much variation. And then chit is a normal ch and t sound, and then sat, a normal s and t sound. So actually the student of Sanskrit's getting off quite easy with their pronunciation of Sat, Ananda, Chit. So let's get right into the actual rules of Sanskrit Grammatometria as it differs from the normal rules of grammar. In any way, it differs from the normal rules of Grammatometria. In its most basic form, it follows exactly the rules of normal Grammatometria, which is to say you can easily apply the normal rules of the four major non-alphabet specific grammatometric orders, 0 through 9 serial, 1 through 9 metric, serial, and metric. You can apply all of those number orders to it, which I have down here, and we'll go through those. Plus you can do a few little tricks that, believe it or not, the original inventors of the Katapayadhi code of Sanskrit, the original number order, they adopted a fairly advanced digital order of Sanskrit, because they were using it more mnemonically, so they were looking for a certain digital code that was easy to remember for the Sanskrit alphabet. So they were kind of looking to boil it down, to be blunt, as far as remembering astronomical type numbers. I mean, you definitely want to be efficient when doing that, you know what I'm saying? Not my cup of tea, but I'll just have normal tea. Let me see if I should have some more twa. Yep. The tway. I need some a little bit more caffeine on this one. I have to pardon my brief break. All right, we're getting in right into the direct ordering of the Sanskrit alphabet in practice. So, you know, of course I've listed results and such, but once you get into trying to list the exact and name, you have to list and name not only the major grammatometric orders as I have described, but within each language you have to be able to abbreviate those number orders as they and identify them specifically to a language in order to separate them in name within what is called a number dictionary. And that's kind of the end result and kind of the end goal of everything that we're doing here. And a number dictionary is just like a dictionary of words, but those words are arranged by number somehow, and using a dominant number order or two. So there's two types. If you want to kind of hear the two types of number dictionaries. Classified as quote number dictionaries because it's just I use just two words interchanged. So the first dictionary, the most sensical dictionary that most people would use when they want to know what a particular word equals, and you can just have at the left of a page. You can have at the left of a page the word, and then at the right of a page its number value in quite a few different number orders is my point. Or you could just use, there's only in most languages there's only really two mainly important number orders to give the values for, and that's the serial and metric order. So in English, if we use the case of English, it's 1 through 26, because there's 26 letters of English, so Z's valued at 26, and then with the metric order 800. So use those two number orders for every word in the English alphabet, and give those values to the right of every English word, and that would be what I technically call a word number dictionary. the word number dictionary of English or the English word number dictionary. And believe it or not, there are actually meaningful results that crop up in relation to historic findings as to the quality of numbers using just that same process called, as I say, grammatometria. So it's the serial and metric order, which will be used in most word number dictionaries, because you kind of would want to be a little brief. Now you could always get detailed there and just use the words, and then use like quite a few to have like a reference manual of a specific, like it would be like a grammatometria focused word number dictionary in that case. But the other type of dictionary, we just went into the word number dictionary. The other type of, quote, number dictionary is a number word dictionary. And that's very interesting too, because that's arranged by number. And that's the crazy complex one that everybody really associates with numerology / Gematria, and my term grammatometria. They think of a dictionary arranged by numbers because what separates grammatometria from just a dictionary is its keenness or wanting. It's will to use numbers. I don't know. It's desire to give words number value is one of its desires, anyway, we could say. And then to classify those number values meaningfully, optimally, but according to number. I'm not even going to use any examples. It's just you can think of a number, and then you can think of a bunch of words below it that all equal that number by fairly standard and worked out historic results. So you're going to have Hebrew and Greek words basically for almost every number series of the first 1 to 2 to 3,000 numbers, because you can start using phrases. Now you don't want to use every phrase, because it gets like a little bit meaningless, like you get into just like broken. You don't want to start using broken sentences and stuff to pepper your results with. That's why it needs like a little bit of a academic scholarship, taking the work up a little bit. But just computer programs would do wonder to grammatometria. But you just can't do it too randomly, because you'll get into adjectives that aren't really important. So you'll just want to do lists of words that people find important, and stuff like that a little bit. You don't have to do the entire dictionary of every word, but we're just using that as an example. You can like there's like philosophical dictionaries. There exists like because most students of Sanskrit have some kind of interest in Hinduism or at least Indian philosophy, there's existent Sanskrit dictionaries that emphasize philosophical terms that like kind of are abbreviated in that way, is what I'm saying. So just like create something like that. The field's pretty wide open for that, especially if you just digitally now, where you can just share a PDF. You can just have a net of words, and then, you know, if you were even proficient with Excel, you could just do those databases, and then with all those number values, and have something where you could really adjust sort the columns that way, and that would actually be a pretty cool way to have a numbered dictionary ordered on a computer. So there really has to be a lot of, unfortunately, a lot of detailed work done. But again, we're just going right into it here, though, with my diagram of Sat-Cit-Ananda, but in the order of Sat-Ananda Chit, written here, which is Ein Sof, R. So I went in that order. It's a pretty much order only philosophized by me as being important. But anyway, it's just father, mother, child. So just think alchemical, the upside down triangle, where the left part of an upside down triangle would be father, the right part of an upside down triangle would be mother, and then the bottom part of an upside down triangle would be the child there. And with that, you get a nice symbolic image of how the father and mother go to produce the quote child. And let's not get too much farther into that. So I wrote it in lesser pen because I wanted to stress the numbered orders. But I've got 1, 2, and 3. There's three. There's kind of three major ways we can number Sat-Ananda Chit. I'm just going to keep saying Sat-Ananda Chit from here on, because that's the way I wrote it, and I wanted to write it that way to emphasize that it's, because that is the major way. It's the what did I say here? Oh, this is a new it's the true way. Yeah, true way. So I actually described it as the true way to write it. Sat-Ananda Chit. And so we get the math here, and I wrote the rules right below these numbers and circles. I can actually just show this really big here. Pretty cool. So Sat-Ananda Chit, and okay, so so you can see these rules, but let me put this paper down real quick. And actually, it gets slightly complex there. Sat-Ananda Chit. So, as I touched upon, it's called the Katapayadhi order of Sanskrit, and it's a digital order, as I've said. It's kind of a digital order. I wouldn't use that term, but when I'm trying to say historically, how it was historically and originally used. It was a digital order used for mnemonic purposes, for large astronomical values. For some other reasons historically too, but let's just abbreviate that. And so how, and then like within the digital order, within just those simple rules of using the digital order to number letters, like we could say ABC would be 1, 2, 3, like that. But since the Sanskrit alphabet usually always has a vowel, I think the term is, quote, qualifying each consonant. So just like this, Ananda, that's why you hear so many vowels with Sanskrit. You don't hear them as much in the example, the word we're using, Sat-Cit-Ananda, Sat-Ananda Chit. The uh, only like word where there's a couple vowels is Ananda. So it lets me address a complex rule unique to the Sanskrit language. But when you really break it down, you wonder, hey, could I use that same rule with other languages? So, who knows? But we'll get into the unique, the unique way Sanskrit numbers its letters and its words. You would think just normally. So let's discuss real quickly what I mean by normal using like Hebrew. We'll use the Hebrew letter R. No, not letter R. The word R, meaning light, which is Aleph, Waw, Resh. That's easy. And it's just, and metrically, it would be, and that's what people's used to. And when I say metrically, that's the order where A equals 1, the U equals 6, and the R equals 200. People should be able to follow me right there. So it's called I call it the metric order because that value of 200, that's not a normal serial progression. The letter R there is actually the 20th letter of Hebrew. All right. So as I call it serially, that resh right there is number 20. But so it's like real logical is what I'm saying. There's no, it's pretty common sense. You would just assign a number series 1 through 22 for the 22 Hebrew alphabet letters, and then you assign the number series, as it turns out, 1 through 400, which fall into the same place value as the first is 1 through 22, and I will here state those values just for clarity's sake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 200, 300, 400. And if you do that using a sequential order, you get 1 through 22. So that's the serial and metric order. And then what I call 0 through 9 serial is taking the units place value of the serial order, and it just goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, etc. And then there's a slight variation upon that really simple serial order that just takes the units place of the serial order. That's why I call it 0 through 9 serial, but you can just abbreviate 0 through 9. So the direct parallel to that is the 1 through 9 metric order, which is based upon the metric order, and that's using the actual highest place of the metric order. So I don't know, it differs whether it's what exactly, whether it's the tens, the 100s, or the thousandth place, but it's always to the left. If you just remember, it's to the left. And then the 0 through 9 serial order, it's to the right in the units place. So if you ever have any question what the values are, you just look to the left or right most value, whatever that is, and it'll be that letter digitally. We're trying to just get simple digital codes. So, okay, an example, the 27th alphabet letter. I instantly know that's 900 metrically by summing 7 plus 2, 900. And then what's the 1 through 9 metric value of the 27th place value number? Valued is 900? 9, because I know 9's the highest leftmost digit, in this case in the hundredths place. And then what? The 27th serial place value number? Well, I know that in a number order using the first the serial values of the numbers. So instead of the number 10, it uses the number 0. Well, in that type of number order, you just simply use the units place of every serial number. So the 0 through 9's number for the number 27 is 7. You just take the rightmost digit in the units place. Always. Real simple. So what? Okay, what? The 34th place value, it's just 4. But what's that metrically? 7. 7,000 is what it is. 4 plus 7 is 7,000. That's what it equals metrically. So that's just kind of how you can add it up real quick. And it's 4 by 0 through 9 serially. It's just that rightmost digit in the units place is 4. So 34 equals 4. It equals 7. It equals 34, and it equals 7,000. Right in that order, because we just start with the 0 through 9, the 1 through 9, the serial, and the metric. And that's the 4 basic ways to order a word, I propose. So I'm glad we got I did touch that and got clarity upon that. If you wanted to include those 4 number values like that, in most languages, that's the 4 most direct ways to number a language. That exists pretty much. We're going over pretty kind of foundational stuff there, but all when getting into these Sanskrit grammatometric codes. So I had to give a kind of a thorough understanding of how to do it normally and basically by those 4 orders, because Sanskrit modifies some rules within itself that modify how you actually apply those 4 orders to the language. And historically, the serial and metric order were never applied to the Sanskrit alphabet. It only used what I have called the 0 through 9 serial order. So, you know those 4 orders we just went through? Sanskrit actually only only used the 0 through 9 order from that list. But I'm actually theoretically expanding the Sanskrit possibility of number orders logically. And so we're going a little bit beyond just Sanskrit's 0 through 9 order. Now, along with this video and the Sanskrit Grammatometria based videos, the student should consult David Allen Hulse's Sanskrit chapter as found in his book, The Eastern Mysteries, which used to be called The Key of It All Series, Volume 1. Okay? So just consult that, and then he'll give those references for further study will be easily obtainable from that work. But we're going a little bit beyond his Katapayadhi number system rules as found in there, but we're touching upon them. So let's get right into it. And here are the values of like Sat using. You wouldn't normally do this, but I have to get right into this. So in the normal rules of Katapayadhi, it doesn't matter kind of which variant the student can look for sure, but there's a few variants of Katapayadhi, but I believe the standard would be not to use these values of the letters if they don't have a qualifying vowels, and that's what these marks mean right here. It's kind of like an apostrophe, like we would know that symbol is an apostrophe. But you put that below a Sanskrit alphabet letter, and that means that letter is not pronounced with a vowel. And so the example with this threefold formula occurs in two of the words, both Sat, which ends in T, and Chit, with ends in T as well. It's not Sata or Chita with a vowel after it. Okay, so take the case of Ananda, and we have an A, which doesn't actually mean anything according to the rules. It's always what's after the consonant. And then we have an N, and then and you don't have to write a vowel in Sanskrit if it's just the letter, the first letter A. This vowel right here that looks like the letter, that looks like the number 3, that's actually the second vowel of Sanskrit, which is a little bit longer aspirated A sound. So it's like a ah rather than an ah. So that's why it's actually included as a vowel. But the letter N there actually has an A sound. You just don't have to write it in Sanskrit. So it's ah, na. And then the last two letters are shown in conjunct form as normally written. It's nda, the 20th letter and the 18th letter, N and D. And by the rules by the particular rule, the most common rules of Sanskrit right there, that conjunct, only the 0 through 9 serial value of the second letter D equals 18, and thus 8, would be considered within the most common rules of Katapayadhi right there, which is unique to, will be unique to Sanskrit, because usually you would, in like the English, in an English word, you would, if you just use the 0 through 9 digital code, you would just take its serial values and then cut out everything but the unit's place. So we'll use the word in quotations word, which is the 23rd plus the 15th plus the 18th plus the 4th letter. And so instead of those values, you would just use 3 plus 5 plus 8 plus 4, and that's 8 plus 12, and that's 20. So in 0 through 9 serial English, the word word equals 20. And likewise, you would think that you would do that same thing with the Sanskrit word Ananda, which has the consonants 20 plus 20 plus 18, which would actually be 0 plus 0 plus 8. But you actually would not do that in Sanskrit. You would just use the first consonant and then the last consonant, because it is the last letter of that conjunct. In this case, with Ananda, it doesn't change the number value, as I show here, because it just so happens that the 20th letter of any alphabet, using the 0 through 9 serial digital code, the 20th letter is valued at 0, whereas the 18th letter is valued at 8. So it actually doesn't change the value of Ananda when using 0 through 9. And that's what the most common way to number Sanskrit is. So let's keep using the Sanskrit common order, and we have Chit, the 6th alphabet letter is a 6, but here we run into the problem, or the case, not a problem, it's just the case that Chit doesn't have a vowel after it. It's not Chita with a A after the T, it's Chit. So by the normal rules of Sanskrit, this letter Chit will not be given value at all. It will not be considered to be numbered. So it's actually just Cha that is given number value. So it's always just 6 right there. Normally, we're doing normal Sanskrit Grammatometria right here. And then this word over here is Sat. There's no vowel after the last letter T either. It's not Sata or anything like that. It's just Sat. So the T doesn't get any number value most commonly. So it would just be the serial letter 7 right here. So actually the way to number this most commonly using that digital order, let me see if I can do this spontaneously. This would just be 6 because you don't even consider the T, and then this would just be 7 because you don't consider that T either. And so N, you would consider this N, but it's 0, you see. And then the ND, you wouldn't consider the N, but you would consider the D. And now the most common way to do this, believe it or not, is then to reverse this digital number. So Ananda, you've got 0, 8. It would be 0, 8. And I kind of do this kind of there, but you would read it backward and then put it as 80. So believe it or not, Ananda equals 80 by the most common way to number Sanskrit, because you end up reading it backwards. So let's just carry on with that. It's 80 plus 7 for Sat plus 6 for Chit, because there's only one alphabet letter that gets numbered in each of those words, and that's 15. 80 plus 15, 95. I think it's called the third variant. I think David Allen Halls calls it the third variant of the Kerala variant, number 3, but don't quote me on that. But you see how we could finally adjust those rules and say, well, maybe all the consonants are numbered just serially, like just in the serial order of English. Maybe we don't reverse the values like Ananda is 80. Maybe we just keep the left and right thing going. So where Ananda now uses that letter N, but it's 0, and then the D is 8. So it'd just be 8. Wouldn't be 80, it would just be 8. But the Sat and Chit would still just be 7 and 6. So 7, 6, 8, 21. So, and then just using the serial values like that, 27 plus 20 plus 18 plus 6. 20, 30, 40, 58, 64. Which I don't even have these values. I must have did it a little different. I've got at the very, let's see what I've got. I don't think I actually did that number code. Yeah, I didn't actually, I just didn't write it down, but you can see it in the serial order, implicit in the serial order. 27, you don't use 16 because it's got the, you got the thing there, which means it's not qualified by a vowel. There's no vowel, it just means don't pronounce it with a vowel, actually. But you know not to number that and within normal Sanskrit rules of numbering. Not to say you shouldn't, like with alternate rules. But we're considering that rule right now, but using the serial values. So where I'm using 27 for S, and then N, I'm using 20 for that N right there. I'm not using this value 20 for the N, the conjunct N that is conjuncted to the letter D, but I'm using the D's serial value as 18. And then I'm using 6 for the ch, the 6-letter ch. So it's 27 plus 20 plus 18 plus 6. So 27. It doesn't even work. Let me see, 27, 37, 47. 57, 67, 66, 65, 71. It's 71. Yeah, I got 71 serially. Oh, I did do that right. 71. Yeah, I did it right according to the normal. I thought I calculated it normally according to, I calculated the serial values for the letters that would be qualified within the Sanskrit rules, which is to say you don't count these letters without vowels. And you also don't count the first letter of any conjunct. You only count the last letter of a conjunct. So I actually described that. I actually just wrote the rule. I didn't try to abbreviate any of the rules. So the very last sentence here for the third rule, all consonants with vowels and only the last letter of the conjunct. So those number values only number those Sanskrit alphabet letters in a word that have vowels associated with them after them, and only then if they're the last letter of a conjunct, like we see with the N and D of Ananda. So, and then the second rule here I use, but this, let me see, including both all consonants with vowels. Yeah, this one, number 2 wouldn't even be found within the normal rules of Sanskrit. It's just you could, and if you wanted the ND of Sanskrit, you could include that in, because it is a kind of part of a vowel structure being NDA. So you could kind of include that if you want, you know, as a possibility. And then the most liberal way to number Sanskrit would be as close to something like Hebrew and English as possible, where you number every consonant no matter if it is qualified with a vowel coming after it, or whether it is part of a conjunct. So you would just name number the entire word. And a good example I just thought of is the word for the a chakra, manipura, in Sanskrit. It's the manipura chakra. It's usually the third from the lowest chakras. You've got Muladhara, Svadhisthana, and then you've got Manipura. I like it as the liver. That's not exactly standard, though. Keep that liver strong anyway. Wow, hoorah. But serially, let's see here. No. That's not a great example because there's no dichotomousness. No, there's no other way to number it except for how it is. Because every word of that is qualified by a vowel. You've got ma, ni, pure, ra. So, I was just going to say serially, numbered serially in Sanskrit, it equals 93, but not entirely relevant because there's no other way to number that word because it doesn't have a letter conjunct. So with Sanskrit it gets a little tricky because the letters are conjuncted together and take on different visual forms. So the number order rules, first evolved is only considering the last letter of any conjunct, and it can get even more than 2 letters. It can get 3 or more letters being conjuncted together within the Sanskrit language. And only that last consonant would be given number value classically, even right at first. So it's kind of interesting. But now, what we know about the very foundations of Grammatometria, we can certainly apply the 0 through 9, the 1 through 9, the serial and metric grammatometric orders to Sanskrit, just as a matter of theoretical exactitude and certitude. That's what it is. Just certitude. Yes, y'all. And I don't stop. Apparently. So, okay, let's see what we're on actually. Yeah, we've got into discussing the actual rules pretty well. So this word is Sat-Ananda with the 27th letter, the 16th letter, the 20th letter, the 20th letter, the 18th letter, the 6th letter, and the 16th letter. Now that's kind of using my corrected Sanskrit alphabet a little bit as far as what I'd said the place values were, but these yeah, as just what I posited this last letter Sat to be in the 27th place value. That's the only discrepancy right there. Because as some listeners might know, I changed the order of the Sanskrit alphabet after the letter Ma, which is in the 25th place value, and valued at the number 5 within the Katapayadhi, number schema and order. So some references are Buller's Indian Paleography, as like a really early source, which proves the Vedic letter La, the letter L with a dot below it, as the number 9, importantly, which unfortunately David Allen Hall's noted incorrectly as being of the value of the number 7 in his Sanskrit chapter, so that's an errata. Absolutely. Because you can both refer to Buller and I believe it's Burnell and his elements of Southeast Indian paleography. And then, of course, refer to David Allen Hall's Sanskrit chapter. And then my videos on Sanskrit Grammatometria. And I'm glad I was able to wear the Punisher hat there, my 2 little pendants, Satan, and then Santa Muerta, Santa Muerta, sorry. Anyway. I don't want to, but we covered it there, so you can kind of, we can fiddle around, and then you can see what David Allen Hall calls these, but let me see if you want to try to discuss the nomenclature. So the actual codes that we use, Sanskrit, like if you wanted, we have to try to abbreviate these codes that we're using so you can put them, write them in a dictionary, and everybody's going to know what you're talking about. So Sanskrit uses traditionally a 0 through 9 serial number order, but it doesn't use it in the traditionally common sense way, because it'll reverse its values. Like I stated for Ananda, where the value of N is 0 and the value of the last D of the conjunct ND is 8, instead of using 0 plus 8 equals 8, it digitally reverses that value and uses the value of 80. So what I would call that process right there going on is 0 through 9 serial digital reverse. That's my abbreviation. But you never have to use the word serial when you use the nomenclature 0 through 9. You would just use 0 through 9 digital reverse Sanskrit, and then as an abbreviation you would say 0 through 9 DRS. So that's pretty simple. 0 through 9 DRS. And then you would know digital reverse Sanskrit. You might have to further refine that definition upon how strictly you use, you apply those rules. So I'm not exactly, hammering I'm not hammering it down exactly now. Maybe in book form I'll try to do that. But it would be digital Sanskrit reverse. And then you would have to specify whether every consonant gets valued or only the last letter of a conjunct consonant gets valued, and whether the last letter of a word that does not end with a qualifying consonant gets valued, you see, even within that order. So very complex once you try to flesh out, we call it, I was calling it plumb before, but it's actually like, quote, fleshing out the number range by using all of these different orders, and then especially like all these variations of Sanskrit. That's what I'm saying. That's why I was trying to use these this Punisher hat. So you gotta really, because I just told you a few orders within the 0 through 9 digital reverse order even of Sanskrit. So so I'm just noting there it could get quite complex. So let me do comment a little bit. I would definitely try to use just the serial. I would try to use a serial metric order on Sanskrit. The metric order would get a little bit too rough because the end letters of Sanskrit go to the 35th place value. The 34th metric value is 9,000, and that's just too wildly high to have too many other words being identified with that number value than perhaps other Sanskrit words at that point. There's not too many alphabets that reach that number value. You would have to maybe use phrases and sentences of other language, and perhaps some interesting stuff will be achieved there, but it's just beyond the reach of current research presently. That's why I kind of like getting these more recondite subjects out here. The subject of Grammatometria, other more commonly known as Gematria or even numerology, and quite lesser known as isopsophy in Greek as of equal stones. I like my word grammatometria, the measure of the letters, because we're basically assigning number values to letters is the most common process, and by that you're assigning measure a little bit symbolically to each letter, and then you're assigning measure to those words as equaling a number value. Whatever that number measure may be, but I guess you're dividing it from the one somehow. But anyway, I like the grammatometria of the word grammatometria as spoken previously as well. It equals 1011, which is the same value in Greek as Apollo. So it that really well exemplifies the brilliant mind it takes to really entertain this subject. You can't really do it all day long. It might fry you out. Just imagine looking at a word number in a number word dictionary where there's numbers being associated, words, phrases, and then every number has a bunch of words being associated to it that happen to equal that number by certain number orders, and are trying to add meaning to that number. You get a sense of what Grammatometria proposes to be, and honestly, it actually floods you with information. You kind of have to parse that data as to what the real meaning is. That's why not everybody will be able to even really appreciate too much. I think as the knowledge gets out there, there's beautiful parts of it which should just keep being kind of used as primary examples, as you do with kind of almost every branch of knowledge. You use some primary examples. Same way with this, we'll be using. Eventually you can get into some of the the most beautiful grammatometric results, and when you do that, you're basically just showing off fancy words and what it does. You're not it doesn't seem as novel as it is. It turns out, more or less, you're just showing off the most wonderful words of every language. Because even a cursory, a lot of people will branch out and try to make their own number dictionaries, and there's some online, and there's been enough cursory study of the number research implicit in Grammatometria to get an idea of the basic results, of course. And it's very wonderful. I kind of lost my train of thought on that. Anyway, I think just the way okay. The most meaningful results of Grammatometria will always be the most meaningful words of every language, philosophically. So there's a lot of magic to Grammatometria, and so you just kind of have to follow the magic philosophy of reality, and some of that naturally branches into Grammatometria once you do an exegesis and an expurgation and begin to expound upon the subjects in a natural decipherment of knowledge almost. You want to employ Grammatometria, honestly. I guess we can use those quotations, the old yogic scientist. And but you have to kind of use that because philosophy, more or less, is examining words a little bit, because philosophy is concepts, and concepts are words. As it kind of happens, either kind of words, phrases, a lot of it. So that's kind of how Grammatometria starts to gain hold in people's use of it. is because they really love certain words, or certain words hold a lot of meaning. Like you could say the Greek word logos, and that's the word for, quote, the word. Concepts like that, word, the word, because like that kind of gets, even with the Bible, the Word of God, it's kind of like the breath of God. Kind of even, you get the image of a breath flowing over the waters, like a breath of air, a spirit of air flowing over the waters. It's kind of the breath of God. It's kind of a common image. I think maybe Christians have been maybe taught that, or it might be a common Bible visualization. I'm not sure. I'm not even sure where I was going with that. It's kind of like the Word. Oh, okay, the Word. That's kind of the beginning of the Word of God. So once you kind of hone in on the concept, in quotes, word, the word, the Greek word for word is logos. And that did kind of, see, that kind of individual concept did get harped upon by the Greeks themselves, even as a kind of first principle. Heraclitus uses that word. So, anyway, just stuff like that. So that's a perfect word to kind of think what is the number of logos, and kind of add it up in Greek. When you add logos up in Greek, it equals 373. And then when you attach the Greek letter for the word the in English, it's omicron. So when you put an omicron before the word logos, you get o logos, and that means the word, and that equals 443. And that's kind of important. Important number to consider. Not for, like, I don't want to do cognitive grammatometrics, but just look that up. Logos and o logos is kind of cool in Greek. It's a major order. I don't think I have probably too much, but actually that's a bizarre thing. Maybe I should have pulled up my number page. Let's see what 440, if I have anything too much for 443 recorded. Not really. I mean, you guys don't want to hear this one that in metric English it would be Lucifer, the light bringer, which means light bringer in Latin, Lucifer. And English, metric English, where A equals 1, Z equals 26, the word Lucifer is 443, and that would be the word in Greek, but that's a little bit silly-willy unless you actually assume Lucifer as like kind of the gnosis bringer, the word bringer. Yeah, I guess you could do like the ray of light. A ray of light there. So we actually went through all of Sanskrit and kind of probably got on a little bit of a sidetrack, but I was trying to give some of the rules. So if we've stuck through that, yeah, man, because that really gives you an appreciation of the complexity of the Sanskrit alphabet. Way to number the way to number the Sanskrit alphabet historically. The way they did it historically kind of complexifies the way we might do it now. There's still major ways to do it. You just have to carefully define your rules within any work to give some examples, stuff like that. You don't want to get any confusion within the Sanskrit alphabet as far as trying to number it. But boy, wouldn't those results be nice. You can kind of do it pretty easily using an online Sanskrit dictionary, because once you get those rules down, it's kind of easy. So just because, well, it's not super easy. It would be easier if the Sanskrit alphabet, if the Sanskrit dictionaries were ordered with that code in mind. It would be really cool. So I hope to really, it would be wonderful to see a lot of reform and a lot of just, because you could do it just, online PDFs now, using those Katapayadhi values, like instead of the letter the letter chit and the sixth letter cha is valued at 6. So how about if you had a conjunct like two sixes? There's a, I'm not sure if that starts a word. It usually doesn't start a word. I'm not sure what you would need like there's various conjuncts. And if you could order those conjuncts and what they equal to begin with within the Sanskrit dictionary, that would be a simple way. And you could even do a really abbreviated Sanskrit dictionary to hone in on important words with just those conjuncts listed. So where everything's really nice and clear, that would be some cool stuff to do for the future, in the future. Getting all those Sanskrit values hammered out would be real cool, though, because that's so much great philosophy within that language. So combining that with the extant knowledge of Hebrew and Greek, grammatometric values, would be superb. So Sat-Ananda Chit, and that triune formula right there can't underplay its magnificence. Sat-Ananda Chit is the triune formula in Keter. In other words, this is the magical mixing bowl of Keter. It's what's in the magic mixing bowl of Keter. Sat-Ananda Chit. It's the components of the magic. Being, bliss, consciousness. Father, mother, child. Will, love, light, sulfur, salt, mercury, Sat-Ananda Chit. Those form to create the Pneuma Hagion, the pure magic